Solution stoichiometry. Two solutions are mixed, 50 mils of 0.150 molar barium chloride, 75 mils of 0.12 molar sodium sulfate. First, we'll write the balanced equation by correctly writing the formulas for the reactants. Barium ion is a +2, chloride is a -1, sodium is a +1, sulfate is a -2. And then we predict the products. Cation of the first with anion of the second. +2, -2 comes together in a 1-to-1 ratio. Cation of the second with anion of the first. +1, -1, cation before anion, comes together in a 1-to-1 ratio. And now we'll add coefficients to balance the equation. And then use solubility rules to determine what the precipitate will be. Chloride salts are soluble. Sodium salts are soluble. Sulfates are generally soluble, but barium sulfate is not. So we've determined what our precipitate will be. Next, write the total and net ionic equations. Barium chloride is a soluble salt. Barium has a +2 charge, and there are 2 -1 chlorides. Sodium sulfate is a soluble salt. This 2 indicates that there are 2 sodium ions. And this 4 is just part of the chunk of charge that we know is sulfate. Barium sulfate is our insoluble solid, so it stays together. It doesn't dissolve, so it can't dissociate into ions. Sodium chloride is soluble. There's 2 sodiums and 2 chlorides. Next, we're going to cross out anything that is the same on the left and the right. The spectator ions, 2 chlorides on the left, 2 chlorides on the right. 2 sodium ions on the left, 2 sodium ions on the right. And then we rewrite what is left over. This is our net ionic equation. Now we're going to determine how many moles of each reactant ion we have. And to do that, we're going to use molarity times volume to get to moles of the formula unit. And then we'll look at the cations and the anions separately. So we have 50 mils of 0.150 molar barium chloride. Instead of writing molar, I'm going to take that nickname and write down what it means. It means moles per liter of solution. If I want my units to cancel, my milliliters and my liters aren't going to cancel. I'm going to need to either use a conversion or rename something. So instead of saying 1 liter, I'm going to say 1,000 milliliters. And now my milliliters cancel. Every time a formula unit of barium chloride breaks apart, it breaks into 1 barium ion and 2 chloride ions. So I have 0.00750 moles of barium ions and twice as many moles of chloride. For sodium sulfate, we have 75 mils of 0.120 molar. Rename molar. Get it so my units will cancel. We have 1 sulfate for every formula unit, so 0.00900 moles of sulfate ions when the soluble salt dissolves and dissociates, and twice as many sodium ions. Now, working from the ions will determine which is the limiting reactant. So I go to my net ionic equation. And I see that initially, before the two solutions are mixed, working in moles, I have 0.00750 moles of barium and more moles of sulfate. If all of the barium is consumed, not all of the sulfate is consumed. So we can see that barium is the limiting reactant and sulfate is in excess. Okay, so in the last slide, we determined how much product was produced. Using the molar mass, we can determine how many grams of product that would be. Now we'll determine the number of moles of each ion remaining. We know that there are no moles of barium ion. It was the limiting reactant. When we subtracted what we had of sulfate, what we needed from barium and what we had of sulfate, we found out how many moles of sulfate remained. And at the very beginning, we did calculate our moles of spectators. Now let's divide the moles of each ion by the total volume to determine the concentration after mixing. we had 50 mils of the barium chloride solution. We added 75 mils of sodium sulfate solution. We now have 125 mils total. I convert that to liters. And as you know, molarity is moles of solute. So we're going to look at each ion as a solute particle individually, divided by liters of solution, which is 0.1250. The concentration of sulfate is 0.00150 moles divided by our new volume. And finally, we draw the picture. Before we had sodium and sulfate ions floating around. In a different container, we had barium ions and chloride ions floating around. But when we mixed them, we have 125 mils with a precipitate at the bottom. Barium was a limiting reactant. There was a little bit of sulfate left over, so sulfate ion is still floating around. The sodium ions and the chloride ions were spectators. They are present, but they didn't participate in reaction. Thank you for your time.